that is viscosity. Viscosity of the fluid. Viscosity of fluid. For this, to understand this concept in a simple way, I am explaining about one example. Suppose it is a rough surface. It is a rough surface. On that, a solid body is there. If you apply the force P on this body, then that body can be moves in this direction. Moves in the direction. Here, this body can be contact with this particular surface. With this particular surface. So, in this, if you want to move this body, the force will be applied in this direction. But in between this body and this surface, some opposing force is acting. Some opposing force is acting. That opposing force in the motion of the body, that opposing force in the motion of the body is called as the frictional force. The opposing force which will resist the motion of the body. The force which will resist the motion of the body is called as the friction. In a similar way, suppose number of fluid particles are flowing in a channel. Here, these are the number of fluid particles flowing in a channel with some layers. These are first layer, second, third, and fourth layer. Now, if you apply the shear force, flow means there will be some acting of shear stress. Here the terminology tau is equal to shear stress. Tau is the shear stress. To move the fluid particle, we have to apply some small amount of shear stress. Then, if you apply here, the shear stress will be acting on the top layer. The top layer will be moves, but the top layer will be in contact with the second layer. So the second layer will be opposes the motion of the first layer. The second layer will be opposes the motion of the first layer. Okay, in the similar way, if the first layer is moves, then second layer will be opposes its motion. If the second layer moves, the third layer will be opposes the motion of the body. And if the remaining three layers are in the moving condition, then the fourth layer will be opposes the. So that property, that opposing, that resistance property is called as the viscosity of the fluid. That resistance property in the motion by the adjacent layers, by its adjacent layers, is called as the frictional force. Frictional force. Okay. It is called as the. This is the from. This is. Now, for this, to know in the definition point of view, that is that the resistance offered by the adjacent layer is called as the shear stress. Now, to know the remaining concept, we have to know about an important law, that is Newtonian's law of viscosity. Newtonian law of viscosity. Newtonian law of viscosity. Newtonian law of viscosity is shear stress. That shear stress is proportional to the rate of change of velocity. Rate of change of velocity with respect to distance. That is, if the first layer will be moves with the velocity of u, and here the distance between the adjacent layers is taken as the y. The fluid flow velocity is u and the distance between the adjacent layers is y. So this ratio is the rate of change of velocity with respect to time. So this is the Newton's law of viscosity. The statement is shear stress is proportional to the rate of change of velocity with respect to time. Rate of change of velocity with respect to time. So this can be written as tau equal to mu into du by dy. Tau equal to mu into du by dy. It is a very important relation in any competitive examination point of view. Shear stress equal to mu into du by dy. If the any fluid satisfies this condition, that fluid is called as the Newtonian fluid. That means the fluid which will obeys the Newton's law of viscosity. Newton's law of viscosity, that is called as the Newtonian fluid. Whereas the fluid which does not obeys the Newton's law of viscosity, that fluid is called as the non-Newtonian fluid. That is nothing but tau is not equal to tau is not equal to mu into du by dy. Du by dy. This is the difference between Newtonian and non-Newtonian. Newtonian means that will be satisfies the condition of Newton's law of viscosity. Non-Newtonian means that will not be satisfies the Newton's law of viscosity. Now here mu, what is mu? Mu is the coefficient of dynamic viscosity. Coefficient of dynamic coefficient of dynamic dynamic viscosity. Coefficient of dynamic viscosity. Okay. Now let us know about the what are the units for the dynamic viscosity. Now take the formula, that is the same thing. Shear stress tau equal to mu into du by dy. We know that. Then the shear stress, what is your target? You have to identify the coefficient of dynamic viscosity. It can be written as tau by du by dy. Tau by du by dy. What are the units of tau? Tau means shear stress. Shear stress having the units of Newton per meter square. Whereas du by dy, du means velocity. Velocity is having the units of meter per second. Whereas dy means it is the distance. Okay. From this, by the simplification, we can write Newton per meter square Newton per meter square. By here meter gets cancelled 1 by second, then it will become second by 1. So then its units are Newton second per meter square. Newton second per meter square is the units for the dynamic viscosity. Units for the dynamic viscosity. Why? Because there is one more viscosity is there, that is discussed later. Dynamic viscosity having the units of Newton second per meter square. Newton second per meter square can be also written as Pascal second. Pascal second. Pascal second is also an unit for the dynamic viscosity. Why? Because 1 Pascal equal to 1 Newton per meter square. 1 Pascal equal to 1 Newton per meter square. Okay. And here one important thing is one more unit is for the dynamic viscosity. Important unit is for dynamic viscosity. Poise is the one more unit for the dynamic viscosity. That one poise can be written as one poise. One poise can be written as 1 by 10 Newton second per meter square. One poise equal to 1 by 10 Newton second per meter square. These three are what are the three? Newton second per meter square, Pascal second, and poise. These three are the SI units for the dynamic viscosity. SI units for the dynamic viscosity. And what are the MKS units for the dynamic viscosity? MKS units are kg force second per meter square. Kg force second per meter square. Whereas the CGS units for the dynamic viscosity is dyne second per centimeter square. Dyne second per centimeter square. Now we should know the what are the dimensional formulas. Dimensional formula for the dynamic viscosity. Okay, in the next video, we will discuss about the dimensional formula and kinematic viscosity. Okay, and one more important bit is for the dynamic viscosity, the dynamic viscosity of dynamic viscosity of water at 20 degrees centigrade is 0.01 poise. 0.01 poise or 1 centipoise. Water having the dynamic viscosity of 0.01 poise or 1 centipoise. 1 centipoise. Okay. Next, this is about the complete information about the dynamic viscosity. Okay.